15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on the podcast we like to call Space Nuts. My name's Andrew Dunkley. Now, before we get to Fred, I have to answer a criticism that came through that I was disrespecting Fred by not giving his proper title. So, let me introduce Dr. Fred Watson, astronomer at large with the Department of Industry, Energy and Science. Hi, Fred.
That's nearly me. You're very close with the department, and that's very good.
It's hard to keep up because they keep changing their names.
Industry, Innovation and Science.
Oh, that wasn't on your. That's not on your email signature.
Yes, it is.
I'm going to have a look right now.
And if you really want to be pedantic, as your listener clearly does, and that's good. Pedantry is good. It's actually Professor Watson.
Oh, is it?
Yeah.
You've never told me. You probably have.
You
know what I'm like.
So, yeah.
But all is well, Fred.
So see, I'm a plastic professor, which means what I've got are adjunct professorships. But the nice thing is, I've got them in 6 universities. So nearly everywhere I go, they welcome me, which is very, very nice.
Indeed.
Yeah, it's very nice. They don't throw me out.
I know people think that I haven't been away for the last couple of weeks, but I have. My wife and I went to Hong Kong and China and Macau for a little holiday. So we crammed sessions before I left. So now we're up to date and we're back ready to go. But one thing that disappointed me about my trip to Hong Kong, I didn't get to go to the Hong Kong Space Museum. I had it slated, but then when I was ready to go, it wasn't open till 1 p.m. and we had to get out to the airport by 3. So I missed that. I was all ready to report on it, but I did eat deep fried intestine.
Yes, well, look, it's from one extreme to the other, really, isn't it? Yes. I don't know which is worse, missing the space centre or eating deep-fried intestine.
Oh, I can tell you what was worse. Yeah, it was like eating a giant rubber band. That's all I can say. The one thing I didn't eat, although I did see it in a market in China, was a cage full of live snakes.
Oh, okay, right. They would probably have been fairly tough as well.
Yeah, probably tastes like chicken. Now, today, we better get down to business. We're going to talk about the demise of Opportunity on Mars that NASA has finally announced. We thought about it for a while, but they kept trying to get it back, but no. And Ultima Thule, it's been called the Space Snowman. Now it turns out that's wrong. They've done a Harpoon test to try and pick up some space junk. Elon Musk is changing the design of his rocket to send people to Mars. And we've had a question about whether or not dark matter actually exists. So we'll get into that. But first, Fred, Opportunity is no more.
Yes, RIP Opportunity.
This is a lost opportunity.
Oh, we're back, aren't we? We're back. It is actually, it's not lost. NASA knows exactly where it is, but it ain't doing anything. And that's because we think, anyway, that the dust storm which enveloped a lot of Mars during the northern hemisphere summer of last year, in other words, the middle of the year, that dust storm almost certainly covered the solar panels of Opportunity to the extent that the amount of sunlight that they were receiving was diminished below what could acceptably be used to charge the batteries, because that's the key thing with the solar panels. And once the batteries go flat, then you've got no power just to keep the electronics warm, and the Martian night drops in temperature well below minus 60 Celsius. That's probably about minus 30 or thereabouts, minus 40. No, sorry, mine, it must be of the order of minus 50 or thereabouts.
Yeah.
Fahrenheit. No, it must be minus 70 Fahrenheit. I can't do these calculations in my head anymore. I'm out of practice. Anyway, it's cold, and so that freezes the electronics, and once that happens, things tend not to come back to life. So the last signal that was received from Opportunity, if I remember rightly, was on June the 10th last year, and the mission controllers have kept on sending little bursts of signal to the spacecraft to try and wake it up, including, I think, I can't remember what it was, but there's some rock music was sent out there as well, just in case it needed some entertainment. None of which actually produced any results. So with much regret, because Opportunity has come to be regarded as one of the great space missions of all time, with much regret, the mission has been brought to an end. Remember, it was in January 2004. That's 15 years ago, more than 15 years ago, when it touched down on the surface of Mars with a kind of life expectancy of 90 days. So it's done 60 times better than that.
Which is remarkable, yeah.
It is extraordinary. The statistics, it's covered 45 kilometres, about 22 miles or thereabouts. It's more like 28 miles, sorry. I'm doing my calculations wrong again. It's also holds the record. Here's an interesting one. It holds the record for traversing the steepest inclination of any space vehicle. At 32 degrees, it went up a slope 32 degrees, which is, if you were in a car going up something like that, you'd be terrified.
I think, you might be able to correct me, I don't know, but I think the Victoria Peak tram comes down the mountain at about 32 degrees.
Yeah, that's right. In Hong Kong, yes.
Yeah, and I went on that. It is mighty steep. That is a real achievement. Yeah.
Well, this didn't have, it didn't have the rack work holding it on or anything. It just had its poor old wheels. So an extraordinary achievement, yeah, and a space mission to be celebrated.
Yes, indeed. Well, it had to happen one day. So, it's finally over, but it did a lot more than they ever anticipated, and you can't say that about all space missions, but this one was extraordinary. We also wanted to talk about another thing that seems to have not been what we thought it was, and that was Ultima Thule. Now, this is the asteroid that was passed over by the New Horizons spacecraft on January the 1st. And it's since been sort of designated the Space Snowman because that's what it looks like. But no, it is not.
Yeah, that's right. The flyby on January the 1st, we got images back fairly quickly showing this thing that looked like two balls stuck together, very much the snowman shape. And I think actually you and I spoke about it again because a detailed image was released at the end of January showing craters and various features that were starting to be interpreted by the New Horizons team. But then about a week or so ago, and we're now sort of mid to late February, the new imagery was released, which shows that it is not what it seemed to be. So there are images now showing the object, Ultima Thule. It's this Kuiper Belt object, 6.5 billion kilometers from Earth, about 4 billion miles. And it is quite clear from this sort of flyby imagery as the spacecraft is looking back on Ultima Thule, having gone past it, and seeing the dark, the unilluminated side, with just a little sliver of light around the edge. It's quite obvious that this is not two spherical blobs stuck together. It's two pancakes stuck together.
Yeah.
It is very different in shape from what we expected, and really resembles exactly that. They're not quite pancakes. They're more like two pebbles that are stuck together, sort of in parallel. So when you look at them from what is currently the side being illuminated by the sun, they just look like two spherical balls. It's quite remarkable. Yeah. We've been hoodwinked by a major optical illusion there, I think.
Now, that prompts the question as to whether or not this is a common thing or if we've actually just stumbled across something out of the ordinary.
I think it's the latter, from my understanding of what the planetary science pundits are saying, that yes, we understand how spherical things form, and in fact, spheres are what you get when when an object grows big enough that its gravity overcomes the internal resistance. So, that's why planets are spherical, because the gravity pulls them into a spherical shape. And that's why, with our perhaps naive view, we expected that this curious object, which was presented to us, fully illuminated by the sun, of course, because the spacecraft approached it from the inner solar system, which is where the sun is. So what we saw was the full Ultima Thule, in the same way as we see a full moon illuminated by the sun. And it looked for all the world like two spherical globes stuck together, and it's only when we've seen these images of the backside, and you might say, well, how do you know it's that pancake shape when the thing's not illuminated on that side? And the answer is, it's not illuminated, but it blocks off the stars behind it, and so that tells you what shape it is. There's it's fairly easy to find on the web. There's a little movie sequence showing Ultima Thule whizzing through past the stars, and you can see just by looking at it that this is two flat things stuck together.
Yeah, and that thinness is what was apparent with the stars behind, and if it was spherical, there would have been a circular
exactly
blockage.
That's right. So, but your point is well made, that this is probably, we think this is something fairly unusual, and indeed it's something that the theorists, the people who build models for how these things work, are really going back to the drawing board with. They're really having to think hard. How you get something like this, two shapes, both flattened, that kind of stick together, more or less in parallel, with their. And the other thing that's interesting is their rotational axis goes right through the join. So when you look at it from the sunlit side, it appears to be rotating sort of like a clock face. It's not, it's spinning with an axis that's right along the line of sight, as we saw when it approached. Very interesting stuff.
So asking you how it happened would be pointless, because no one seems to know at the moment. But maybe it got smashed into from both sides simultaneously. I don't know. It's hard to figure out. Yeah.
So I think the one thing that is coming out of this now is that this is probably something that happened very early in the history of the solar system. So the pundits are suspecting that it's been like this for the last 4.5 billion years.
Wow. Well, we just need to turn New Horizons around and go back and have another look.
Yeah, that's quite tricky, actually.
Yeah, you can't do it.
I tried putting the brakes on at 14 kilometres per second. It didn't do you much good.
No, not really. You'd burn them out pretty quickly.
Yep.
Okay, so it seems that every week or two there's something new to learn about Ultima Thule, so watch this space.
I think there'll be more too.
You're listening to Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Ta-da!
0G, and I feel fine.
Space Nuts.
Now, Fred, we're going to revisit something we've discussed before, and this is the problem of space junk. There's so much garbage out there that we've put into space that it's reaching a point where they're starting to worry about, the assets orbiting Earth that are working, communications satellites, for instance. So they've been trying to figure out ways to clean up the mess, and one of the ways that was being touted was using harpoons. Well, the good news is they've done a test.
Yeah, this is all about the spacecraft that you and I have spoken about several times before, I think, which has the slightly self-explanatory name of remove debris.
Yeah, that's just, I mean, they took several months with massive committees to come down to that. I mean, that can only have been figured out by a committee.
Yes, that's probably true. It's probably a terribly eminent committee as well. So
probably.
Yeah.
Sorry.
Remove debris, a product of a group in the UK led by the University of Surrey. And its mission was to test out different technologies for attempting to clear the Earth's environment of all the debris that's hanging around up there. So remove debris is a good name for it.
I would have thought, Eliminator 1 or something like that. Give it a ballsy name. Give it something.
Clean up 53. How's that?
That's nearly as bad for it.
That it is, yeah. So this thing was launched from the International Space Station, actually. It went up on one of the transit spacecraft. Was launched from the International Space Station, if I remember rightly, it was around about this time last year. Don't quote me on that. And one of the tests that was done was to use a net to grab onto bits of passing space junk, and because the net is self-closing and is also attached by a tether, you can then use that to deorbit the piece of space junk. So the real step that has to be taken with this stuff, and by the way, there are somewhere between 7,500 and 8,000 tons of debris up in space, ranging from the tiniest little pieces to huge rocket bodies that are spent. So the main aim is to take that bit of space junk and slow it down, because slowing it down brings it down nearer to the upper layers of the Earth's atmosphere, which slow it down further, and it undergoes this fairly catastrophic dive into the atmosphere, which almost always results in it burning up, basically evaporating in the atmosphere. Once in a while, if there's a large object, you can get some debris which makes it down to the ground. Nobody's ever been hit by any of this stuff yet, but it's always a possibility. But it's actually quite rare. And in fact, for the larger bits, the bits that are harmful, they are tracked by radar. So people kind of have a fairly good idea where they're going to come down. You might remember Tiangong-1, the big Chinese space station, which came down last year. And towards the end of its descent, even though it was out of control, people had a pretty good idea where it was going to land. And actually, it landed right where you would have put it if you'd had any control over it.
Oh, wow.
There's a region in the South Pacific Ocean.
Same with Skylab.
Yes, that's right. Skylab, bits of Skylab.
In the Indian Ocean.
Yeah, bits of it came down in Western Australia as well.
Yeah, but Western Australia,
Careful. There's a big radio telescope there. That's
what I was going to say is it's a very remote country. So if you got hit by something in Western Australia, it's very sparse. You'd be the most unlucky person in the world, I reckon.
You would actually. That's right. And of course, it's that sparseness that makes it a good place to do radio astronomy from.
Yes,
just giving a plug there for the square kilometre array. So that's right. So the aim is to slow things down. And so if you can attach some sort of, almost like a parachute, a kind of membrane to a spacecraft, what it does is it increases its cross-section, which means that the thin atmosphere that there is up there has a much greater effect in slowing down the spacecraft. So the two ways that have been tested with the removed debris spacecraft at the moment. First of all, the net, but now the more recent one, which is the Harpoon. So this is great stuff. You fire a harpoon at your target satellite, and it's got barbs on the end, spring-loaded barbs, that because there's enough weight in the harpoon to penetrate the titanium or aluminium shell or whatever it is of this spacecraft, the barbs open up, and then you've got a really good hold of it. And if the other end of the harpoon cable is attached to something like a membrane or a parachute, then that is going to have the desired effect in slowing it down. And that was the purpose of the test, to show whether you can actually harpoon something up in space without basically destroying your own orbit by the recoil. The trial seems to have gone flawlessly. All the reports I've read are glowing about the performance of the Harpoon. So maybe that's a technology that would be worth developing.
Oh, much cooler too.
It's cool, really. Cooler than a net, yeah.
Definitely. Yeah. But I just think it's really interesting that they're using fishing methods to
well, that's right. It's the same problem. Yeah. It is the same problem. I have to say, I'd much rather see harpoons used on spacecraft than on whales. Mm-hmm. And so, it's very good use of all technology. There is one final experiment to be done by removed debris, which will be done probably within the next couple of months, and that is to deploy a device exactly like I've been talking about, a parachute or a kind of membrane, a solar sail, that will actually remove debris itself back down to Earth. So they're going to try out the ultimate method of deorbiting it on the spacecraft that's doing the tests. Which
that answered my question, because I was going to say, is removed debris ultimately going to become debris?
Well, it already is, but well, actually, it's not. It's still got useful experiments to do. But that's right. If that step hadn't been taken, then it would become space junk itself. But it's not going to be done like that. So its height is roughly 400 kilometers. That's well above the last. How can I put it? It's above most of the Earth's atmosphere. You know, you're well above most of it, but there is still enough up there in terms of the really rather thin layer of air that exists at that height to act as a brake on these deorbiting objects.
Okay, good one. Well done. Except for the name. But well done. Yeah, good job. Now let's move along to a man that just keeps making headlines in the world of astronomy and space, and that's Elon Musk, who has announced some design changes for his rocket booster, which he's planning to send to Mars with 100 people on board. Now, there was another plan to send people to colonise Mars, which only this week has been announced as a no-go.
Yep.
We won't say that about Elon Musk, but what's he doing to his spaceship?
Yeah, this is, once again, something we've talked about before. It's not very long ago that he renamed this spaceship because it was the BFR, if you remember.
Yes, which spawns all kind of
It does indeed, but it was the big Falcon rocket, because his rocket
Sorry, what did you
series
say?
Is the Falcons. Listen carefully. Okay. The big Falcon rocket.
Right. I'm sure that's what you said.
It's so his series of rockets they're called the Falcon, and he renamed it the Starship, which is really rather an elegant name.
He's talking about that same committee that came up with the...
somehow I doubt it was a committee. I think that could have been an executive decision there. What's more of an executive decision is to propose a novel method of heat shielding the spacecraft when it makes its touchdown on Mars, because the idea behind this is that it will take 100 tons of cargo and 100 passengers to Mars at a time. It is monumentally ambitious. I will not share my personal views of taking people hundreds at a time to Mars. It remains to see how it goes. But his new idea for preventing the spacecraft burning up in the Martian atmosphere, because that is what happens if you simply descend through the Martian atmosphere at orbital speed. Whereas the space shuttle used thousands of ceramic tiles to dissipate the heat, Elon is proposing a method that actually was suggested back in the 1960s, and that is to cool the outside of the rocket, of the spacecraft, with liquid. And in fact, what you would use probably is rocket fuel. There was a suggestion, I think, patented in 1965, and put a little warning here. There's a warning for a definitely politically incorrect comment, but they were going to use cooling spacecraft by astronaut pee. Oh. So they would use stored urine and put that around basically bleed it out through holes in the spacecraft to cool the spacecraft. That was patented in 1965. Elon has taken that idea and cleaned it up a bit and turned it into something which may well work. Apparently, if you do that, this liquid, of course, it vaporizes because of the heat, but forms a boundary between the plasma that is generated by the friction of the spacecraft on the air and the body of the spacecraft itself, which is also made very highly reflective. So
but who gets out and pours it on the front of the ship?
So it's got tiny holes all the way around it, and it bleeds this stuff out. It's almost like sweat glands. So you don't have to have somebody pouring it on. It just comes out on its own. Now, riding into Mars on a spacecraft with little holes in it everywhere through which liquid is going to seep seems to me to be not that great an idea. But the engineers are looking at it and saying, well, it's 100 times more difficult than landing Curiosity on Mars was, but it's got a chance of working. And you can bet your boots it'll be tested to death. So it's a really interesting thought.
Yeah, I can't get past the idea of pouring fuel on a fire.
Well, that's right.
That's what it sounds like.
Yeah, well, indeed, that's right. I think the stuff will probably burn, but its cooling effect will have been enough to stop the spacecraft melting. That's the theory.
Okay. Interesting idea. Very interesting idea.
That's
All right, we'll watch with interest. I'm sure there'll be more on that. It's Elon Musk. We'll definitely have more on Elon Musk at some stage, because he's always finding something interesting to consider. And often he follows through on what he says he's going to do too. Just ask the people of South Australia, who've got a nice battery, the biggest battery in the world, in fact. You're listening to Space Nuts with Andrew Dunkley and, of course, Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, to a listener question, and we had quite a few turn up over the last couple of weeks, and we were all set to sort of tackle one or two of those, and we will get back to them, assuming you didn't delete the email. But one turned up today, which sort of got us thinking. It comes from John Brooks. Hi, John. Thanks for the question. And this is an interesting spin on something we've talked about many times, and it is rather thought-provoking. I'd like to leave a comment/question. Scientists, theorists, and the like continually write articles about dark matter as if it's scientific fact, whereas it's just a theory. I'd like to see you report on the ever-increasing experiments from all over the globe that have failed to show the existence of dark matter, and the list gets longer every month, and then these same theorists and scientists come up with new excuses and theories to explain their null results. I find it hard to believe that we can look at a galaxy and or a universe and estimate its total mass of every single particle or atom in said galaxy and universe. It's fake science to say we can measure the weight of our own galaxy or others when we don't even understand basics like gravity. Just saying. I'd like to know your thoughts.
Well, thanks, John. And the first thing to say is it's not really fake science. This is science, and it's how science works. What we do is we look at every piece of evidence that points to any given phenomenon and try and make sense of it. And so the evidence that has come about to suggest that there is dark matter in the universe, principally, as you've said, it comes from the way galaxies rotate, the way galaxies behave in clusters, the way galaxies bend the light of more distant galaxies in this phenomenon we call gravitational lensing. And all of those point really strongly to there being something which is not detectable, but which has mass. And so you're basically, you're confronted with immediately with a conundrum. There's a puzzle, and the puzzle is that we know that things behave as though there's something very massive there, which became known as dark matter, but we've failed to detect it directly. So when dark matter became a real problem for astrophysicists, which was actually in the late 1970s, thanks to the work of a scientist called Vera Rubin, sadly no longer with us, but a great female scientist. She was the person who really alerted people to the fact that there was something wrong with our understanding of the universe, and that actually it had been noticed years before. It was back in 1933 that the first evidence came about, but nobody took any notice of it until Vera actually pointed it out, and then people really got hold of the idea that there is something missing in our understanding of the way galaxies work. So the first thing that happened, almost the first thing, not quite, it was in the early 1980s, is a scientist by the name of Mordechai Milgrom in Israel. Can't remember which university he's at, might be Tel Aviv, can't remember. He said, well, there must be another way to explain this. These weird effects that we see, galaxies rotating too fast to stay together, and clusters of galaxies circulating too quickly to stay together. So he proposed that our understanding of Newton's dynamics is wrong. In fact, what he proposed was something called MOND, and MOND stands for Modified Newtonian Dynamics, which suggests that when you have very, very small accelerations, and by an acceleration you can kind of read it as gravity because the two are interchangeable. In other words, feeling the gravitational force of a planet at a very great distance rather than in the immediate environment of the sun, or more especially the gravitational effect of one star on another. Perhaps gravity does not work the way we think it does at those very, very low levels of acceleration. And so MOND was proposed. He wrote papers on it. It was analysed to death and found really not to do the job. Yes, it got rid of the need to have dark matter, but it gave you all kinds of other problems. It meant that our understanding of the way the universe has expanded all went completely cockeyed, and that flies in the face of other observations which themselves are really secure about the way the universe has evolved. It also meant that some of the things that we take for granted within the solar system wouldn't have worked either. So it's not now generally accepted as being an explanation for dark matter. And it has to be said that most scientists do believe that there is a subatomic particle species that we're missing because it is not detectable. Now, John's right in that there have been experiments which have been designed to look for the possibility of a dark matter particle interacting with a normal matter particle. And that's the problem. We know from all the evidence that these interactions are incredibly rare. So there are experiments which are kind of hoping to find an interaction from time to time. We've got a precedent for this because we know that there are particles called neutrinos, which themselves barely interact with normal matter. I can't remember the exact figure, but it is something like if you fire a bunch of neutrinos through half a light year of lead, half of them get through. It's that kind of statistic, because they themselves really don't interact. Yet we can detect them. Rarely there are neutrinos detectors which pick up, 1 in a gazillion of these things. And the theorist suggests that dark matter should be similar. There should be. It's probably at an even rarer level, but there should be interactions. We look for evidence of that both in the laboratory and in space. There is the likelihood that when dark matter particles collide with each other, they annihilate, a bit like matter and antimatter. And that would produce a very specific signature in the gamma radiation region of the spectrum, which people are looking for and have not yet unequivocally found. So the experiments are really all about, in a sense, they're backing up what John says. They're trying to disprove dark matter, but we've got no other explanation at the moment for the way galaxies behave. And so that conflict will continue until there is positive evidence of some dark matter particle. The likelihood is that it'll be something that turns up, probably not now at the Large Hadron Collider, because that seems to have exhausted its current energy levels.
The Larger Hadron Collider?
No, there's something called the FCC, which is not what you think it is. It's the Future Circular Collider. And
that's
whereas the Large Hadron Collider has a diameter of about 8 kilometers, this one has a diameter of 100 kilometers, I think. So it's the plan. Actually, no, it's not. It's the path length is 100 kilometers. So 27 kilometers for the Large Hadron Collider, 100 kilometers for the FCC. That just to perhaps wrap this up, dark matter is only one thing that doesn't make sense in physics. There are a few other things about what we call the standard model, which is this model of 17 particles that make up everything we know. There are some aspects of that which are very esoteric that themselves don't make sense. So scientists are very much of the opinion that there is new physics out there. There are new physical processes whose nature is currently not understood. And that's why science is so exciting, because people are looking for those. And the experiments that fail to find anything are part and parcel of all that. They're not fake science. They're the way science works. I just hope that we do find out what that dark matter particle is. The odds are it's something called an axion, or maybe something called a neutralino. These are two suspected theoretical particles, but we haven't got there yet. And I hope that I will be around still when we do, and more especially, I hope you'll be around as well, Andrew, so we can talk about it on Space Nuts.
That's the plan. That is the plan.
Yes.
But I suppose I can bring it down to my level by drawing a comparison. We not many people that I know of deny the existence of black holes, and yet we've never seen one, but we know from the behaviour and the mathematics that they exist. We're on the verge of seeing one, and I would put dark matter in the same category. We can tell by the way things are interacting and moving that there's something out there.
Yeah, it's a matter of time. And look, if it turned out that the weight of evidence shifted towards it being something like MOND, modified Newtonian dynamics, it won't be that, because that's ruled out by other aspects. But if if scientists quietly started realizing they were barking up the wrong tree, then they would change it. As I said, that's the way science works. That's exactly what happened with Pluto. Scientists over 20 years realized that Pluto simply did not have the attributes which you would you'd consider as being what a planet should be, and so it never was a planet. So they adopted the view that yes, Pluto is something different. It's a dwarf planet. It's a perfectly respectable dwarf planet, and it's known to have those criteria.
Funny you should mention Pluto, because in my book I actually do focus on the decision to take planet status away from Pluto. It comes up in the story with the main character and a Dr. Fred Wilson, interestingly enough.
Who could he be?
I don't know. Very astute fellow indeed. But I would like to thank John for his insightful question. It's certainly probably the subject of astronomy at the moment that's getting a lot of tongues wagging.
Yep.
And so thank you, John, and we'll get to some of the other questions that turned up in the last few weeks in future episodes. Thank you as always, Fred. It's a great pleasure. I'm off to my book launch tonight. We're going to do. Of
course you are. That's right. Yes.
Yeah, I got a specially made Shanghai to launch it, and she'll be up and running. But I would like to say thank you to the people who have come back to me with their reviews, because I did ask for feedback, and so far nobody's picked the twist. I'm so pleased about that. But all positive comments. People have really enjoyed the story, especially the way it keeps twisting and changing. It just catches them off guard. They think they know what's going to happen, and then it changes. So I'm really, really happy that that's happening. It seems people have got joy out of it. Thank you, Fred, as always, and we will talk to you again next time.
Yeah, I hope the book launch goes really well, Andrew, and I look forward to hearing about it next time we speak.
Fred Watson, astronomer at large from that strange Australian federal government department. And we will catch him next week, and I will catch you next week here on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.